Hello, welcome to my channel Devops with Prasanna. This is day 19 in Learn AWS in 30 Day series. And today we are going to talk about managing secrets in production. So for this, we are going to use AWS KMS to encrypt and decrypt the secrets. There are like lot of ways in which you can manage secrets in production, but this is my preferred way, and this is what I'm using pretty much in most of my client projects. So yeah, we'll quickly see a demo of how things are going to be. So we are going to create a secret file, and we are going to encrypt that using a technique called envelope encryption using a tool called SOPS. And we are going to encrypt the secret, push it to the GitHub repository, and we're going to make some changes to the secret and push it again to the GitHub repository. Then we'll see what are the advantages, how it compares with other tools as well. Yeah, I'm very much excited. Let's get started. Criteria for managing secrets. So before going into see the demo about KMS, these are the 5 criteria which I always use. The first one is able to do proper versioning. For example, if you have a secret file, you should be able to version your secrets also, which means for release 2.3.0, this should be your secret file. For release 2.1.0, that should be a different set of secrets. So you should have a way to have a proper version. The second one is the audit information. You should be able to find who changed and what was changed. So this is also something which is very important when managing the secrets. And the ability to roll back. So in case of rolling back to previous version, you should be able to roll back your secrets also. So that should be some efficient way to do this as well. Then different users should have different environment access. For example, few users should have access only to development and staging, and certain set of users should have production access to production secrets also. So there should be a way to do this as well. And yeah, the last point is only right people can view or update it. Okay. So these are the criteria which I always use when trying to find a tool to manage the secret file. Okay. We are going to talk about a technique called envelope encryption. This envelope encryption means when you're having a secret and you want to encrypt it, instead of encrypting it using a single key, we are going to use multiple keys to encrypt the secret file. So let's take an example, we have a secret file. Okay. We'll be encrypting that secret file using something called as data key. Okay. This will be coming with a tool called SOPS. So this is a tool which we are going to use, and this is given by Mozilla. It's an open source tool. It's coming from Mozilla Foundation. So we'll encrypt the secret using the data key, and we'll be getting an encrypted text. This whole encrypted text again is going to be encrypted using AWS KMS. And this key is called as master key. And this key is called as data key. Okay. So there are 2 encryption involved here. And this is going to be our encrypted secrets. And as we see here, the step is going to be we are going to do envelope encryption. We are going to use AWS KMS as a master key and do one more encryption. And we are going to push the secret into production. So even if it's going to be a public repository, persons who have access to this data key and to this master key only can decrypt the information. Other people can't decrypt this. And even if one key got compromised, people will not have access to other key, so they can't see the the actual secret file. Intro to KMS. Before jumping into the demo, I quickly want to give an introduction to KMS. So KMS stands for Key Management Service. And this is one of the managed service by AWS, where they'll be storing the keys for us, and we'll be getting an ID to access that key. And all the permissions and other things to access the key will be managed using IAM itself. So there are 2 types of KMS key. One is AWS managed key. The other one is customer managed key. So if you remember in the section with S3 and CDN and RDS, we have used the AWS managed keys. I'll give a link here so you can go and check that one. So the AWS managed keys, it's mostly used for AWS based services. So for example, if you want to do encryption at rest in RDS, relational database, then you'll be using AWS managed key and all the information which is stored in the database will be encrypted using this key. But we won't be having access to that key. Like AWS will be managing all those keys. In case of customer managed keys, like the one which you're going to see in this demo, there is a secret file, and we will be using this key to do the encryption and decryption. So there are two type of keys. One is a symmetric key and the other one is a asymmetric key. This is a very generic terminology and which is not very specific to KMS. Okay, so symmetric key means like one single key is used for encryption and decryption as well. Okay, that is called a symmetric key. In case of asymmetric key, it's a pair of keys. So like there's a private key and there's a public key. Like the public key can be used to encrypt the information and private key can use to decrypt the information, or the vice versa also. So for example, when you are trying to SSH into a EC2 instance, we use the key pair, which is a public key, private key pair. That is a asymmetric key. If you are cloning from GitHub repository, you'll be using this asymmetric key, where you'll be adding your public key to the SSH keys in the GitHub, and you could be able to download the GitHub repository. So these are the two keys, and for our demo purpose today, we are going to see the symmetric key encryption. Okay, so this is what we are going to see in today's demo. There is going to be a secret file. We are going to create AWS KMS keys, customer managed key, and we are going to create a config file for SOPS so it knows what is a KMS key it has to use. And we are going to encrypt the secret and then going to push it to the GitHub repository. Then we are going to update a value in the secret. Then we are going to push the secret again to the GitHub repository. We are going to decrypt the secret and see what is the value is. And also we are going to have like path-based access, meaning for development, there are going to be like certain users who will have access to the secrets. For production, there are going to be like different set of users who will be having access to production secrets. Okay, so this is the demo which we are going to see. Yeah, let's see the demo now. Okay, so the first step is going to be, we are going to create a secrets file. I'll create a folder called vars. Within that, I'm going to create a folder called development. I'm going to create a file called secrets.yaml. Okay, so I'm going to say like hello world secret some message env's development. Okay, so I'm creating three secrets here because it's a YAML file. I'm following the YAML structure. Okay, so now the step number 2 is we are going to create the KMS keys. So I'll go to KMS. As you can see, there are two keys available: AWS Managed Key, which are the keys used by RDS Lambda, and then there is Customer Managed Keys. So I've already created two keys. Now I'm going to create one more key, which is going to be a symmetric key. It's used for encryption and decryption. And then I'll say next. The name for key is development. Okay. So there are like two type of users for each and every key. One is a key administrator who have the access to grant permission to others or revoke permissions. And the other one is the actual key users. So I'm going to make Prasanna as an administrator, and I'm going to make Prasanna as a key user, which means he can use this key to encrypt and decrypt the information. If you remember, we already mentioned like KMS, in the KMS service, all the access is managed using IAM itself. So if the IAM user has access, then it means like the actual user can do the encryption or decryption. Okay. So this looks good. It's a symmetric key and the name is development. And this is what the permissions are going to be, which is good. Okay. So we have created the key. I'll just copy the key ARN. Now what I'm going to do is the third step is to create the SOPS configuration. So I'm going to create a file called .sops.yaml. Okay. This will be within the within our day 19 folder. Okay, so we can check this out. This SOPS YAML, it's going to follow a specific structure. And before going there, Mozilla SOPS. This is a tool which we are going to use. So it's for managing the secrets. Okay. So you can check the detailed description here on how to use this tool and things like that. So now coming here, we are going to have a very simple structure. So I'm going to copy this and I'm going to remove this ARN. So you can see this rules is based on path. So for example, for this path regex dot development dot slash whatever it is, this is a KMS key it's going to use. And the key is going to be this ARN. Okay, so it's going to use this KMS key. And similarly, we'll create one more rule for production. We are going to use a different key. So I'll say, maybe like I'll not use this key as of now. I'll create a folder here called production. And then I'll create one more secret here. Secrets.yaml. I'll say env as production. I'll say like production secret, okay, to distinguish the key. Some secret value. Okay. Now here we need to give a key for production. So what I'm going to do is I'm going to create one more key. I'll name it as production key for managing. Again, it's going to be Prasanna. User is going to be Prasanna. And all the other things looks good. It's a symmetric key. Cool. So I'm going to copy this ARN and give it here. Okay. So things looks good now. Now we'll go to the third step. The third step is going to be encrypt the secret. Okay. So now if I come here, if I go into day 19 folder, you can see we have a batch file. And if I do lsafnga, you can see there is a sops.yaml file. What I'll do is I'll text this visible. Okay, so now we have two paths, development path, production path, and we have two different keys for it. Okay, so like there are different ways in which we can use SOPS. Either we can directly use a tool called as SOPS, and we can give the file there. Or we can use a tool called as Helm. So I'm planning to take a detailed session about Helm, Kubernetes and things like that. But just to give a very short introduction, Helm is a package manager for Kubernetes. And because it's going to be like most of my clients, they are Kubernetes. For most of the time, I'm using this methodology to encrypt and decrypt the secret. Okay. And Helm supports the plugin model. So I'm going to use a plugin called as Helm Secrets. So Helm Secrets plugin. Okay. So this is the plugin which I'm using. And this is how I'm going to encrypt and decrypt the secrets. And it's based out of SOPS tool. Cool. So if I want to encrypt this file, I'll say Helm secrets encrypt and then the path to the file. So I'll say vars development and secrets.yaml. But before giving this one, I'll make sure like I have the proper permission. So if you remember, it's like the KMS key works based on IAM permission. So I'll say export world of Prasanna. I'll confirm like I have access to S3. Cool. Now I'll say Helm secrets encryption development is my path. Okay. So secrets encrypt. So I'm saying like encrypt this secret file. If I go here and if I see my actual file, you can see hello secret and env. Okay. Cool. So the file got encrypted. So you can see the information is hello, but the value is encrypted of AES-256, which is the encryption algorithm it's using. And it will have some meta information like what is the KMS key being used And the SOPS is not limited to AWS KMS alone. You can use GCP KMS or Azure key value pair, or you can use a HashiCorp Vault and things like that. So it has support for all these other tools as well. Cool. So I think like this looks good. Now what I'll do is I'll say day 19. Git add day 19. If we search for this, you can see I have development, I have production also. But the problem here is the production is not encrypted yet. So what I'm going to do is I'll going to encrypt the production also. So I'll say if the name is secrets.yaml production. Okay, I'll go to day 19. Cool. So you can see the production is also like encrypted. You can see the keys, but not the value. Okay. So now I'll say git add 19. Okay. I can see the difference also. Git staged. Okay, so all the keys are encrypted, and this is what we are going to save in Git repository. So I'm going to say git commit. Cool. So we could able to encrypt the secret and then push it to the GitHub repository. Okay. Let's see a very quick flow of how to like update this one. Let's say like instead of having it as a secret, I want to have it as like a development secret. Okay, this key and the value is also going to get updated. So for this, I can say Helm edit day 19 Helm edit .vars development secret. Okay. Now if I say edit, we can see it will come automatically in the plain text format, because that's how like we want to we'll know how what are the information to edit. So I'll say like secret development. If I save this file, it will edit the file, and then it will again encrypt it using the data key and master key, which we have already seen. So if I go and see the development.secrets, you can see it's going to be secret development, and then this is going to be encrypted. And you can see this particular file and this particular line got changed. And what I'm going to do is I'm going to say git add FNP. And this is the only line which got changed. I'm going to say yes. The last modified date got updated, and the MAC information is also updated. I'm going to say CST updated secret information. Cool. So now if I go to my GitHub repository, if I go to my commit history, you can see there are two commits. One is a commit the secrets. So you can see like who committed this particular secret. But you can't see the value because it got encrypted. Now, if I go to my next commit, you can see what got changed. Like this in this particular commit, the key which is called secret, it got changed into secret-development, and the value of it also got changed. And you know like who committed this file, because there will be like a commit author history and all, commit author and history information. So you know like when it got changed and who changed the secret information. Okay, so like this is how you can easily encrypt the secrets and store it in GitHub repository. Okay, so we reached the end of the session. I hope like you like the way in which I'm storing and managing the secrets. So this is a way I'm managing secrets for like nearly past 5 years now. So you can consider this as like a very good way, and it has very good audit information also. Yeah, hope you enjoyed this session. If you have any feedback or question, please let me know in the comments. Happy learning. Bye-bye.